Students, this is NCERT exercise problem 2.60 from page number 72 of structure of atom, right? So let's read the statement. The velocity associated with a proton moving in a potential difference of 1000 volt is 4.37 into 10 raised to power 5 meter per second. If the hockey ball of mass 0.1 kg is moving with this velocity, calculate the wavelength associated with this velocity, right? So in this question, they compare two conditions. Now, in first condition, there is a proton whose potential difference is 1000 volt and it is moving with a velocity of 4.37 into 10 raised to power 5 meter per second. Now the second condition is there is a hockey ball whose mass is 0.1 kg and having the same velocity that is associated with this proton, right? And you have to find the wavelength associated with this hockey ball, right? So for this we'll write de Broglie equation, right? So according to de Broglie equation, lambda, that means wavelength equal to h by mv. Now h is Planck's constant and its value is 6.626 into 10 raised to power minus 34 joule second. M is mass of this hockey ball. You are not supposed to take the mass of this proton, right? So you'll mention 0.1 kg over here. Now velocity of this hockey ball is same as that of this proton, right? So 4.37 into 10 raised to power 5 meter per second is the velocity. Some students are confused with this potential difference. You're not supposed to take this value because this is just for the reference. If you see, this mass of hockey ball is in kg and velocity is in meter per second. To cut the units, I'll convert this joule in terms of kg meter per second, right? So for this, I'll write 1 joule equal to 1 kg meter square second inverse square, right? So simply put the value 6.626 into 10 raised to power minus 34. I'll replace this joule with kg meter square second inverse square. I'll mention this second with this, right? I'll cancel this second with this 1 second inverse, right? So Planck's constant in terms of kg will be 6.626 into 10 raised to power minus 34 kg meter square second inverse, right? Now we will put the values. So lambda equal to h, that is Planck's constant, 6.626 into 10 raised to power minus 34 kg meter square second inverse divided by mass of this hockey ball, that is 0.1 kg into velocity of hockey ball 4.37 into 10 raised to power 5 meter per second. I'll cancel kg with this, 1 meter with this and 1 second inverse with this, right? So lambda equal to 6.626 into 10 raised to power minus 34. Now this 0.1 can be written as 1 by 10. Now this 10 will be in denominator, right? So I can simply take this 10 in numerator. So it will be 10 raised to power 1. Now this 10 raised to power 5 is positive in denominator. When I'll take this value in numerator, it will change its sign. So it will be 10 raised to power minus 5 divided by 4.37. Lambda equal to, when you'll divide 6.626 with 4.37, your answer will be 1.516 into, these powers are in multiplication, so you can simply add them. 10 raised to power minus 34. First of all, I'll mention negative powers, right? Minus 5, then plus 1. Now unit I am having meter over here, right? So lambda equal to 1.516 into 10 raised to power minus 34 minus 5 will be minus 39 plus 1. Lambda equal to 1.516 into 10 raised to power minus 39 plus 1 will be minus 38 and unit I am having meter over here. That means wavelength of hockey ball whose mass is 0.1 kg and velocity 4.37 into 10 raised to power 5 is 1.516 into 10 raised to power minus 38 meter.